On Monday, I had the opportunity to hear one of our professors, Peter Juncker, speak about the physics of breakfast. This topic in particular was really neat because it related physics to something really simple that we deal with every day, breakfast foods. I think a lot of times when I think of physics, I think of it in more of an academic or mathematical sense, so it was different to be able to envision physics in my everyday life. In particular, the speaker spoke about coffee, eggs, and cereal. When talking about coffee, I learned why coffee rings happen. I don't think I've ever really wondered that before, but it was actually really interesting. So, to do a little experiment, my roommate drinks coffee every day, and so she gave me some of her coffee, and I'm gonna put it on some paper. So if you pour the coffee on paper, then it kind of looks like this. And so it was really interesting actually to see that, because the actual liquid of the coffee gathers together in the center, but then after you let it sit for a while to evaporate, and this is another one that I did earlier, and if you can see this one, all of the darker stains are around the corners of where the actual coffee was spilt. And so we learned that the stain is actually darker around the edges because of the suspension of the oil particles in the coffee. Particles are pushed from the middle of the droplet to the edges because they're attracted to each other. And they're also attracted to the paper they're resting on, so the coffee actually changes its shape to cover the greatest amount of surface area while still being able to stick to itself. This also made me think about the pattern of evaporation of the actual liquid, of the water in the coffee, which I'm assuming has something to do with it. Since most of the liquid is concentrated at the center of the droplet, it should evaporate faster at the edges. And as the edges evaporate, the coffee stain is left, and so then more liquid would move from the center to the outside of the actual coffee droplet to fill in that evaporated space. And so I think that probably adds to the darkness of the stain as well. Next, Juncker talked about scrambled eggs. More specifically, he talked about proteins. Proteins have two parts that cause something called protein folding. Some parts of protein like water, while other parts don't like water. And so protein folding is when the protein changes its shape so that the parts that don't like water are protected from water, while the parts that do like water are on the exterior and they're able to touch water. So he was explaining that eggs are just a long and extended network of these proteins that stick together. Lastly, the speaker talked about the physics behind cereal. You know when you're almost done with your breakfast and you only have a couple Cheerios left and they all clump together in your bowl? Well, if not, I'm about to do it. So I'm using this little bowl and I have a couple of Cheerios, and I'm using water because I didn't want to waste my milk. Not that doing experiments is a waste or anything, but you know. So yeah, if you can look into it, I know it's a little difficult, but you can see that these three Cheerios are all clumped together. So I learned that this is actually because of the surface tension of the liquid that they're resting in, so in this case the water. Around each of the Cheerios is an upward shaped meniscus, and so the Cheerios climb each other's meniscuses so that they touch one another. I thought this was actually really cool because there are so many other examples of the same thing that happens, just like in hot chocolate when you put those little marshmallows in it and they all stick together in your mug. So yeah, overall this lecture was actually really interesting, and I was surprised by how much physics can be crammed into something as simple as our breakfast foods.